Yes, I can hear you.
Okay. Is that you, Catherine? Catherine, are you there?
Yes, I am.
Okay. I'm going to wind up just sitting where I am because I can't figure out how to get up on stage.
Okay. Would you like to start?
Sure, I'll start.
Okay.
What we're doing is the unit is going to be on the periodic table. This is a physical science class that Catherine is teaching. So the class is this part of the unit is going to come after the students have already done experiments with different elements in the periodic table, so they get to understand how some of the chemicals react and what what is matter, what is um, elements, compounds, mixtures, and all that. What the students would do is pick ultimately five elements that they are going to present. And Catherine and I were talking about if everyone winds up picking the same ones, we would ask them to pick maybe six or seven, and then we would make sure that there were enough elements covered throughout the whole class, so that we want to really get the students to have as much information about more elements. And then, did you want to talk, Catherine, about how they would be doing that?
Sure. The students, this whole theme is based on all students are scientists, and we want the students to feel comfortable in the classroom and make mistakes and learn from those mistakes. And they love mysteries and solving problems, like most scientists. So, what we want to do is encourage them to investigate through the internet and through textbooks using their literacy skills to actively learn by creating a book or a story about each element. So they have five elements to choose from. So they're going to choose their elements and say they pick helium, which if they do an investigation, they can make up a story about the Greek god of the sun, Helios, and kind of go from there and develop a storybook using their ideas, and we can display it, and they will also do a peer review. They also can do a poster through Glogster or um, in my school we have a wonderful art department, so I'm going to be doing this lesson in the next couple of weeks. So I talked to a science teacher, or excuse me, an art teacher who said she has foil paper that little scraps that we could use and have students, use that to embellish their posters or their storybooks. So I think using the school, the other departments in the school, will also help. They're doing their research in the computer lab, so the literacy skills are strengthened using their technology, narrowing down their searches by using keywords, and negotiating in their groups. Sometimes groups don't work well together, so having them establish their groups and negotiating how they're going to divvy up and do their research is really helpful, especially with seventh graders, because some of them just don't want to work. So if we can assign them a role first and then have them all come together, it tends to flow very easily. But it would make it more efficient if they were in groups and doing their own investigations. So I think it encourages motivation and ownership that way. But that's what we had. Did you have anything else to add, Linda, or am I leaving something out?
I just wanted to say that I had located a book on the elements, and it had every element that's been discovered thus far, and different components, like where it can be found in nature, and even to be able to have the students use that book. We would display their either book or their poster within the classroom, and maybe even go out into the hallway so that the other classes and the kids could see the work that they had done.
This is wonderful, ladies, and I like how you've used different departments, different approaches, bringing in the Greeks, bringing in books. So I think it's a very rich project, and it shows that science isn't isolated, gives a sense of the history of science, too. So I really look forward to it, and honestly, it's not as easy to teach elements as maybe some other parts of science, so I really congratulate you on that. So thank you very much. And while
Thank you.
yeah,
Thank you.
I'm going to switch over to our physics folks. And then we have one more after that, so if you don't mind just hanging out a little bit longer, so you can hear your colleagues out, I think you'll benefit from their ideas. And I'll turn my mic off, and our physics people are going to give their 2 cents.
All right, so our unit basically revolves around, it's called Get a Job, and it revolves around the theme that we want our kids to eventually get jobs someday. And physics deals with mostly juniors and seniors, and a lot of them are starting to plan out, what they want to do with their lives after high school. So this is a good way to introduce different careers to them in science that, oh, I'm sorry, this is Larry, Ben, and Steve. Or, I'm sorry, Ben.
Eric.
Larry, Eric, and Steve. I apologize. So, for this unit, we're exposing them to new careers in science fields, and we want them to think like professionals. So, for a lot of their labs, for a lot of activities, they're going to be role playing as different professionals. And then at the end of the unit, they'll be coming together for one big project where they get together as a team of design professionals and design components of an amusement park. So one example of something they would do during the unit, we designed a lab where they took on the role of a safety engineer, and they had an employer, and this employer came to them and said, we're going to be working on a project later in the year that's going to involve springs. We're going to be designing some safety systems, and there's going to be a lot of spring components. So we wanted to learn a little bit more about springs as a company. So I found this great simulator. It simulates all this stuff with springs and mass, but I don't know how accurate it is because I didn't make it. So what I'd like you to do is take the simulator and test it and decide how accurate it is. So the kids will look at the simulator, they'll play with it, and then they'll actually replicate what they see in the simulator in real life with springs and masses in the lab. And they will write a report, basically assessing the accuracy of the simulator. I'm going to hand it off to Eric now, who can tell you a little bit more about some of the other examples of some of the career-related stuff we'll be doing in the unit.
Okay, can everybody hear me? Testing. Okay.
Go ahead, Eric.
I just wanted to quickly say that I really like this our project, and one of the main reasons is it's not just because it's our project, but I teach in Schenectady, and a lot of kids just don't know what jobs are out there. Like, we have several, it's a really quickly developing tech region, and a lot of the kids just don't even know that Global Foundries and nanotech and stuff like that are there. So, they'll go and flip burgers because they just don't know. So I really like, I like our project for that reason, among others. I want to talk really briefly, because it's past my bedtime, about specifics that we have incorporated into the unit. One of them is a lesson, inquiry-based, and it's one of the first lessons where they just basically try to attain a concept of what energy is and what energy conversion is and what it means. And the centerpiece of that lesson is the water wheel. The beginning, they'll try to come up with images and words and physical sensations, very generally, for what they think of when they hear the word energy. And then they're going to break into their expert groups, which are basically like lab groups with roles that are divided up. I think Larry mentioned that each role is a different job, a different career path. And one of the roles in one of the lessons is even a career counselor, so that person's job is specifically to investigate various careers and jobs that fall in line with the project. But during the web quest, they're going to ask very general questions in the beginning, like what is energy? Where does energy come from? Can it change? Can it disappear? Can it appear? And then get into more like real-world situations when energy is converted from one form to another. And, the water wheel is a great example of a renewable energy conversion scheme. and then talk more about renewable energy and why is the water wheel a form of renewable energy. So that's one of the lessons. Another one is quickly. It's called Request, and that's where the students design their own tests at the end of the unit, and they kind of play the role of teacher too. They get to ask their questions to the teacher, and I've actually used this in my practical physics class, and the kids love it. They get to drill the teachers, and then then they're going to at least know a few questions on the test because they're the ones who wrote them, and it's sort of an underhanded way to get them extremely familiar with the content, because it takes a lot more thought to design a question than it does to answer one, and also to justify various wrong answers. That even takes more thought, actually, which I'm sure you all know.
Eric,
Quickly,
Eric, since we're running a little short on
one of the
time,
labs that we included
yeah, how about you
was
just
to
wrapping
have
up
the
your
kids
slide?
design a roller coaster, which is directly related to our culminating activity, which Steve will talk more about. But that's the one where we used the data probe. We used PhotoGates and a TI Inspire, which is like a handheld computer. They collect data and analyze it in Excel, and want to further investigate relationships regarding energy conversion. And it's stuff that they began with the Water Wheel WebQuest, and they thought about and chatted about on the class website too. Yeah, and instead of giving them, this one of the most fundamental laws, or perhaps the most fundamental law in science, and that of conservation of energy, instead of just giving them that, they have to think about questions regarding stuff like that. Hey, could there be some kind of relationship which governs energy transfer, and if so, what is it, and how does it play out in our labs and in our lessons? So with that, I will turn it over to Steve.
Okay, I'll go quickly, Dr. O'Connor. I heard you chiming in a little bit there. We were going to do one more lab with conservation of energy. Has to do with an energy audit as well. Can everybody hear me? I'm sorry. Okay, so it has to do with an energy audit. So that's another career aspect of it. Then we were going to go into the culminating project. I'll talk about the culminating project for a second. Our culminating project was going to be a design proposal for a roller coaster. It was basically going to be a team of four and an expert group, like Eric talked about. There was going to be a data collector, a researcher, a designer, and a project manager, all based on the work of the students. Is everybody hearing me? Okay, yes, all right, so again, so they were going to be in expert groups, like I just said, data collector, a researcher, builder, and a project manager, and they were going to have to design a roller coaster. They were going to have some requirements to it, obviously physics-based with velocity and acceleration. The whole point of the project was they were going to be presenting it to a town board. So the students that are sitting in the classroom are going to be a town board that they're presenting it to, and they're going to judge which project they want to include in their amusement park. So essentially the town board will consist of an amusement park safety engineer, members of the Six Flags Board of Trustees, representatives from Con Ed, the local power authority, and the rubric that we as teachers would use to grade the students is the same rubric that the town board is going to judge the presenting group on. So it has a multitasking element to it there. And again, they were going to have to worry about safety, how high, how fast does their roller coaster go, and just does it follow the laws of physics. I know we were quick on time there. That's about as much as I'll say right now to not hold you guys up too much longer.
And thank you, gentlemen. We have our chemistry 2 folks coming up. That'll be our last one. And I just want to thank you all for your patience. And we might have run over a little bit here, but I think we're getting lots of good ideas. And after Karen and Dan speak, I will say goodnight and ask you not to forget to vote. So I'll send you an email too, though. Thank you, and I'm turning off my mic.
I will try to make this quick. Can everyone hear me?